Hello, everyone. I'm going to talk about what we're facing nowadays in real-world VNF onboarding. Um, but first of all, starting with why is VNF onboarding important? Or what's VNF onboarding? I think it's important to reinforce that concept. And I would like to answer that question by telling a story, the NFV story, actually. Very quick, because we are VNF onboarding is built on top of it, and it's better understood when we tell the complete story. Well, NFV, as most of you know, was born about 8 years ago with a white paper uh, written by many of the biggest service providers in the world, where which were very frustrated on the way they were operating, and some of them are still operating boxes at that time, proprietary boxes with proprietary software inside and hardware. This was incrementing the costs of the operations, incrementing the maintenance of personnel, of the general TCO was going up, basically, and came up with the idea of virtualizing the functions of these appliances so that they stop depending on hardware vendor life cycles. So this is when NFV, the concept, was born. But immediately, the years that came after that, the initial NFV efforts were viewed as expensive. So that's actually the opposite result, right? And some of the operators are still considering that virtualization is expensive. And why is that happening? That's because there's a way of virtualizing that is called vertical virtualization or vertical NFV, where operators deploy many stacks in parallel that are doing basically the same. I mean, they let the vendors of the VNFs provide not only the VNF, but the infrastructure that supports the VNF and the management and orchestration tools. And they do it again and again for every VNF that they have, or for at least for every vendor. So they are deploying in a way that CapEx increases because they are paying for multiple full closed NFV stacks. And the operation, of course, is also more complex because these technologies, the virtualization and whatever is happening inside these boxes are generally new to a networking department, and they are still using proprietary and technology that keeps them captive. So that's why NFV sometimes is seen as more expensive, but this is not the vision of NFV. The vision is to have a single telco cloud under the control of the operator, so that CapEx is reduced as you only invest once in a single cloud with a single NFVI and a single management and orchestration stack. And also, operation of this kind of telco cloud is reduced if you follow the NFV vision of using commodity hardware, commercial off-the-shelf servers, for example, white box switches, and open source based software solutions for the management and orchestration stack. So building a network, an NFVI, actually, from commodity hardware means to basically rely on generic technologies, not proprietary chips, ASICs, or server technologies, just white boxes for the networking, bare metal switches, commercial off-the-shelf servers. And nowadays, these kind of technologies, since there are many companies behind the design and manufacturing of these boxes, we end up having the most efficient hardware specifications that we can have. And we actually have very dense switches with 400 gig ports, in the reduced footprint. And this is actually scaling beyond what we can even feel comfortable calling commodity. This is going to the hyperscalable capacities, and a next level is to adopt technologies like the proposed by the Open Compute project, where some statistics, for example, in an important paper that SK Telecom released, energy can be saved in a level up to 52%. It's very important. So we have more space, more energy available, and better service with the servers. And what about the open source software at the management orchestration stack? Well, this is basically answering the question on how do we ensure that the VNF vendors that will plug into this telco cloud are compatible. Well, open source has proved to be the most compatible implementations that we can get. Is providing that. It's providing usually APIs and connectors that are closer to standards, and is widely adopting the most recent technologies as compared to proprietary based applications. So there we have examples like open source Mano, like OpenStack, like Open vSwitch, like KVM, like Linux itself. So we've got our telco cloud, and with that, a commodity hyperscalable NFVI, an open source based management orchestrator orchestration stack, we can say that operators can finally enjoy the power of building their own network services with virtualized network functions that fit best for their operation. So they can select the best components for every function and build and join them together into network services that make sense for their operation. But how simple, how replicable are these network services that they can build? Well, that finally depends on the level of onboarding that we can get from these VNFs. That is what is simplifying the way that operators can actually run these network functions on top of a single telco cloud that they are operating. So VNF onboarding has a lot to do with automation. This is also an extract from the original NFV white paper that says NFV will only scale if all the functions can be automated. And that's actually true because we need to provide a way to deploy network functions in a way that is simpler than deploying an appliance, right? So with VNF onboarding, we aim to build network function packages that are unique, that can be reusable on top of different infrastructures, even if we're using OpenStack or any OpenStack flavor or any other kind of Beam, maybe VMware or a public cloud. So the objective is not only to, with this VNF package, not only to translate it into the deployment of the network services as static functions, as VMs or containers, but also automating the service initialization so that the VNF is started, the services are started as soon as we instantiate a network service. And beyond that, the monitoring, the reconfigurations, and closed loop operations happen also automatically and are available on demand for the operator to use them whenever they need. So this is the real onboarding process, not only the virtualization, not only the deployment, the management, but also the automation of the operations that happen inside the network functions. How do we achieve that? Well, by, for example, in this case, we're showing what we call day zero, that is basically instantiating and managing what we are deploying, in this case, virtual packet core, for example. And we can see that in this way, we get the virtual machines deployed and just that. But what happens with the services that are running inside? So that's what we call day one, to automate the operations inside the different virtualized components so that we can call it actually a packet core because it's already providing the services by including scripts, playbooks, charms that will allow us to start these services and configure them. And beyond that, on a day-to-day basis, be able to monitor, operate in general these network functions so that it becomes an operated evolved packet core. Okay, so the result is a real VNF package, a complete VNF package that models the automation of VNFs from day 0 to day 2. I mean, descriptors and scripts, code, charms that model the end-to-end life cycle of these network functions. So, can any network function be modeled in this way? That's a question that we get a lot, and what I will try to answer in the next section by providing an example of how a real-world complex onboarding process looks like. Recently, we were exposed to the need of onboarding a virtual call session control function from Ericsson, actually. And it was challenging from the beginning because the architecture of this VNF was more or less emulating the appliance. I mean, virtual machines were line cards, or just like line cards, behaved like line cards. And we had an internal virtual network that emulated the bus that we typically have in a appliance, where line cards that line cards use for communication. And beyond that, this internal bus network was used to provide services from the management virtual machines to the data plane virtual machines. And these services were redundant with the services that the cloud already provides, like, for example, DHCP, NTP, storage through NFS, and so on. So we are starting with not only a VNF that is not cloud native, but is actually not even cloud friendly. So what can we do with these kind of network functions nowadays? Well, a parenthesis, we used our distribution of OSM, which is called WhiteNFV. In summary, we do our best to take the OSM-based code and automate the installation and ensure that it is covering all the needs for a production environment. And we are constantly validating this software in the etc plug tests. So what should we aim to automate in this kind of network function? Back to the network function. Well, we can do whatever a beam level orchestrator can do. For example, HIT, OpenStack HIT, can already inject parameters via cloud init, user data, can control hardware resources assignment via EPA techniques like huge pages, CPU pinning, and the like, and control the security that is provided by the beam. And this is a thing that can be partially met with HIT, but anyway, we can do that. And also the things that are unique to NFV orchestration, like, for example, monitoring the NFVI resources that are being consumed by the VNF, monitoring the VNF itself for providing metrics, configuring and reconfiguring the VNF through SSH, through Ansible, through netconf, or whatever mechanism that the VNF exposes for that, and providing scaling even if it's manually or automatically based on a metric. But furthermore, with an NFV orchestrator like OSM, we get a reusable VNF package that can be used in any infrastructure, So OSM at the end is abstracting you from that complexity and translating your VNF package to whatever the infrastructure, the beam is exposing. So we can do a lot, actually. We can do anything with even a traditional VNF like this. Well, things that we could achieve in this deployment were actually we tried to get all the best from all the features that OSM is providing. Like for example, exposing this VNF package from a remote repository, a remote catalog, and this is using the OSM catalogs feature, so that with a single command, with a single instruction in OSM, you can go and grab the VNF package from a remote location. It can be the vendor's cloud, for example, and upload that into the local catalog. You can do the same as an operator and provide your network service packages in a local catalog, in a local private folder or cloud, and with a single command, upload them into your local OSM catalog. And at the end, all that you need after running that command is specifying some local parameters that make sense for your infrastructure and instantiate. We can take care of any security setting, EPA technique through the descriptor. The VNF package already includes what it needs. If it needs to, for example, disable port security, if it needs to set a particular security group, if it needs to set a particular EPA technique for enhancing performance, that's being taken care inside the descriptor. And actually, together with the possibility of modeling static IP and MAC addressing, overriding security settings like this is key for this kind of legacy network functions that we need to onboard nowadays. The world is still not that cloud friendly when it comes to telco network functions. Virtual machines are initialized with parameterized net user data. So the VNF package includes a generic user data file with generic information that the virtual machine needs to start. And we can provide the parameters specific to our local NFVI at instantiation time. So that keeps the VNF package unique and mutable, and we can feed the parameters that we need at instantiation time. Network functions can be also automatically configured. As I mentioned, in this particular case, we provided some configurations in a first stage through SSH and Ansible, and then in a second stage through netconf, because in this particular VNF, first of all, you needed to configure some things through SSH, and then after 5 to 7 minutes, the line cards were synchronized, and then they exposed a netconf server so that you could configure that in a more agile way. So we can adapt to that. We can include primitives in the VNF package that configure the first stage, wait until the netconf server is available, and then finish the configuration through netconf. And actually, this kind of configuration and reconfiguration of VNFs, together with the automation of the underlay through features like SDN Assist, are two of the key values that OSM provides. We also provided specifications in the descriptor for manually or automatically scaling the data plane virtual machines. This is very flexible. We can select which virtual machines we want to scale and when and based on what. And finally, we provided in the VNF package the specifications, the modeling for collecting the NFVI metrics from the beam directly, and also collecting snmp metrics directly from the VNF. So you have both options. And actually, snmp is being supported since release 8, snmp metrics collection, and is key to gather metrics in traditional network functions like this one. We still don't have a Prometheus or telemetry stream in the network functions that we are facing and we are trying to operate in telcos nowadays. So snmp is still used a lot, like we were using in traditional appliances. That's why it's a feature in OSM. Okay, so finally, a couple of conclusions and an announcement I would like to make. First of all, to send the message that any VNF can be fully orchestrated, no matter if it's not cloud native, no matter if it's not cloud friendly. And as we see operators starting to implement VNFs that are more distributed, that are more modular, that require deployments in a weekly basis or in a monthly basis, orchestration is becoming a must and the only way forward to actually be able to operate that network. And as far as we think and we know about the industry, OSM is the only orchestrator in the industry that is completely fulfilling the NFV vision. So now the announcement. This is breaking news because we are making this public today, and we are very happy to share this news with you, with the community. We would like to announce the deployment of open source Mano in a telco production network through our distribution in Telefónica Chile. This is well, we have a press release that is being sent today, giving all the details. We would like to thank the community, all the other distros as well that are also collaborating in moving this open source project forward, and we are sure that more deployments of our distro and the other distros of OSM will come very soon. So thanks to the community. This is a huge thing for us because we have been working in this community for some years now, and this is a message that we are doing things well as a group. Thank you.